actually use our calculator to find the values of various trigonometric functions. And what we want to do is to approximate all our answers to 4 decimal places. And the very first thing you want to do is to make sure your calculator is in degree mode. Your calculator, if it's a scientific calculator, will measure angles in degrees, radians, or gradients. So if you have any questions, consult with me and make sure it's in degree mode as the very first thing we need to consider. Once we know that it's in degree mode, it's a fairly simple thing. So let's find some of these trig values and round them to 4 places. I'm going to use the little calculator that comes with the computer. So for the sine of 79 degrees, 0.234 decimal degrees, what we're going to do is type in 79.234. And again here on the computer's calculator, I'm making sure I'm in degrees. And then all we have to do is to press the sine button. So when we press the sine button, that gives us our answer, 0.98239. And we want to round that to 4 places. So to 4 places, that's approximately 0.9824. So you might want to check that with your calculator. If you don't get this answer, you're probably not in degree mode, so that's something else to check again. Next example we're going to round off to 4 place is the cosine of 87 degrees 17 minutes. First place to start is to remember that 17 minutes, that there are 60 minutes in a degree. So if we take 17 divided by 60, that'll give us decimal degrees like we had in example 1a. And decimal degrees are nice and easy to work with. So 17 divided by 60 is 0.2833. And we're going to round it to 4 places, round everything to 4 places. So we're looking for the cosine of 87.2833 decimal degrees. So to do that, let's get the calculator. I'm going to clear the previous entry. Type in 87.2833. Look for the cosine button, press it, and then we'll round our answer to 4 decimal places, so 0.0473975. When we round that to 4 decimal places, that's approximately 0.0474. So far everything's pretty straightforward. However, when we look at this next one, you might look at your calculator and wonder if you've been cheated because there is not a cotangent button on your calculator. And that's normal. I don't know of any calculators that have a cotangent button on them at all. So what we need to do is, this is another reason we had to memorize the reciprocals. Cotangent's not there, but cotangent's reciprocal is there. The cotangent of 34.7 decimal degrees is the same as 1 over the tangent of 34.7 decimal degrees. So we needed to know that tangent and cotangent are reciprocals. When we do that, let's get our calculator ready. And let me just demonstrate the tangent there. So we're going to clear out the previous entry. We're going to type in 34.7. Oops, sorry. Let me try that again. 34.7. And we're going to hit the tangent button here. And we're going to round that decimal to 4 places. So 0.692438 is just going to round out to 0.6924. Last step is we want to take 1 divided by that. So clear your calculators. Take 1 divided by 0.6924. And that tells us the cotangent of 34.7 decimal degrees is 1.4443 when we round it to 4 decimal places. All right, that's going forwards using our calculators, but we need to go backwards as well. You can think of this as a little guessing game. We thought of some mystery angle. When we typed that in and hit the sine button, we got 0.7347. What we're really looking for is the inverse of the sine so that we can find the angle. And so we're going to look for the inverse sign on our calculator. The notation for that looks like this. Again, that does not mean sine raised to the negative 1 power. That just means we want the inverse of the sine. So let's start with our original problem. Sine of theta is 0.7347. And let's clear our calculators again. So I'm going to type 0.7347. And we know where the sine button is. And on your calculator, probably right above the sine button right here where your sine is on your calculator, you will see this inverse sine function to the -1 power. And whatever color that is on your calculator, you have a button that's called the inverse button or second function or third function or shift, and you'll press that first. So on the computer's calculator, the way I do it is to check off this inverse box, and now I press the sine, and I get 47.2818725. We're going to round that to 4 places. Actually, I guess we don't need to do that one in this particular case. Usually when we're finding angles, we go to 1 decimal place, or sides of a triangle, 1 decimal place. So that was 47.3 that we round, approximately 47.3 decimal degrees. So the mystery angle we started with was 47.3 degrees. We hit the sine button, ended up with 0.7347. So what we just did is we used the inverse sine button as well. All right, we're going to go backwards again. We're going to need the inverse button, but there's no inverse cotangent button because there is no cotangent button. So again, we have to remember what our reciprocals are. So let's start with our problem. The cotangent of theta is 0.4498. And we're going to write that, and here's what I'm doing in this second step. I'm taking the reciprocal of both sides of the equation. The reciprocal of cotangent of theta is tangent. The reciprocal of this decimal is 1 over the decimal. Now let me divide. 1 divided by 0.4498 gives me 2.2232. And now we do have a tangent button, and therefore we're going to have an inverse tangent button on our calculator. So let's type in 2.2232. We know where the tangent is. Above it, it'll probably say tangent to the -1, which is not to the -1. It just means the inverse function. Whatever color that is, we're going to press that button first, hit tangent. We get 65 degrees, and then the decimal portion degrees, 0.7816. Let's round that out. So actually, I just wrote the step down that we took the inverse function. And in this case, if we did want to go to 4 decimal places, that's 65.7817 decimal degrees. So again, when we don't have the buttons, that's when we need to know what our reciprocals are. If we wanted to go to degrees and minutes and seconds on that, let's take the decimal, 0.7817. Let's multiply that by 60. That's going to tell me that it's 65 degrees, 46.9 minutes. If we're going to go to the nearest minute, as this problem was suggesting, find it to the nearest minute. So that would be 65 degrees, 47 minutes. So we need to find an angle accurate to the nearest minute. That's when we need to carry things out to 4 decimal places. In our previous example, we didn't need to go to the nearest minute, just decimal was fine. Well, what if our angle's larger than 90? Well, that is actually not a problem. We'll just do that right now because your calculator knows what angle is in what quadrants, and it knows the all Scandinavian stand carefully, so it knows what will be positive and what will be negative in what quadrant. So let's type in our 253.4 decimal degrees. We'll hit the sine button. We get 0.9583, and round that off to 4 places. And again, your calculator knows that this angle's in quadrant 3, and your calculator knows that sine is negative in quadrant 3. But you need to know what's positive and negative in what quadrant as well. So the next example, we're looking for, to the nearest tenth of a degree, the measures of 2 different angles where the cosine is negative 0.5560, and this could be anywhere between 0 and 360 degrees. So the cosine of some mystery angle, and we're looking for 2 mystery angles, is negative 0.5560. So we're going to do that inverse cosine button on our calculator. So let's get our calculators, clear off our last entry. Let's type in 0.5560. And actually, there is a button on your calculator that changes the sign from plus to minus. So let me make sure that's a negative 0.5560. Then I'm going to take the inverse cosine of that. And it tells me it's 123.7796 decimal degrees. But it only told me one answer. And the directions here are to find the two angles. Let's round that off to the nearest tenth, because that's what they asked, the nearest tenth of a degree. Otherwise, we'd leave it 4 places. And so theta, the angle we're looking for, is approximately 123.8. And that makes sense because we know the cosine is negative in quadrant 2, and this is an angle in quadrant 2. But cosine is also negative in quadrant 3. So we now have to find the angle in quadrant 3. And this, your calculator will not exactly find for you. So the first thing we need to do is to find the reference angle for 123.8 decimal degrees. We start with our angle's initial side on the positive x-axis. Rotate counterclockwise 123.8 degrees to get to our terminal side. There's our 123.8 decimal degrees. Make it perpendicular to the x-axis, and it's always the x-axis. The angle, the acute angle formed by the terminal side and the x-axis is our reference angle. How far short of 180 degrees did we stop? Because going to the negative x-axis from the positive x-axis would have been 180 degrees. So let's subtract that from 180, and that's 56.2. Now, how does that help us? Well, cosine is also negative in quadrant 3. So I have to find an angle in quadrant 3 that has a reference angle of 56.2 decimal degrees. So I'm going to draw an initial side in the positive x-axis, a terminal side in quadrant 3, make it perpendicular to the x-axis. This reference angle must be 56.2 decimal degrees. And the question is, how large is this angle going from the initial side to the terminal side? And the question we need to answer to get that is, how far past 180 degrees is this terminal side? So that's our mystery angle. So let's add 180 because that's the straight angle, plus 56.2 decimal degrees further. And that tells us our second angle, 236.2 decimal degrees. And our calculator would not have found that for us. It just finds the first one for us. So again, the two angles they were looking for is 123.8 decimal degrees and 236.2 decimal degrees, since they wanted us to round to the nearest tenth. And that's using our calculator to find trig values.